on Canvas. All right, so again, welcome everybody. Let's go over the syllabus. So here is the contact information. Then for COVID, like I said just before starting the recorder, please contact me if you're gonna be missing classes due to COVID, and I'll be happy to arrange makeup work for you. So there's no required textbook for this class, but some of the material that we cover is in the textbook that you have for your Physics 1 and 2 course. We're gonna be using Canvas for the course, and I'll be arranging for you to see videos or for you to see some assignments through Canvas. So your request that you use Canvas for it, and you'll be turning in some of the written work through Canvas. As a prerequisite is co-enrollment in Physics 2114. So I'm assuming that everybody has either taken Physics 2114 or is taking it right now. You get the honors credit, which is 4 credit hours, by getting a B in both courses. And that's the rule from the honors college. So your grade in this course is separated from the grade in 2114. So just want to make sure that that's clear. And if you guys have questions, just let me know. So it is recommended that you take Intro to Quantum Mechanics. No, I'm just kidding about that. And then this is the course description for the course that you're taking. It's reserved for students in the honors college. And it would be adding a different intellectual dimension to your designated course. In this case, is the Physics 2. The idea is to cover topics of current interest that are appropriate for a course at this level. And in this case, it could be the role of physics in modern society. So the program for the course, so this is what you would find. These two things are what you would find in the course catalog. But the reality is that what I wanted to cover in this course is something that you don't have time in Physics 2. So Physics 2 is crammed with a lot of things. But one of the things that is not covered due to time constraints is Einstein's theory of relativity. So it turns out that the physics department made a new course, Physics 3, that covers some of the material that we don't get to cover in Physics 1 and Physics 2. So that gets put into Physics 3. But even with that Physics 3 that covers that material, we're actually not able to cover at the level that I want to cover during the semester, Einstein's theory of relativity. So the theory of relativity has several tenets. One of them is that the speed of light is constant. And we're going to understand that from how Einstein figured it out and some examples of time dilation and then contraction. Another aspect that would be presented is, and due to Einstein's special theory of relativity, is how electricity, magnetism, and optics are connected to mechanics. So this is one of the major accomplishments that Einstein did. And we're also touch upon the general theory of relativity. So I don't know if you guys know the difference between the special theory and the general theory. Anybody? No? So the special theory is what Einstein came up with in 1905. And the general theory is from 1915. So 1915, it took him 10 years to figure out how to put together what he had figured out for light, but now for gravitation. And it has some major consequences. For instance, black holes, the expansion of the universe, all of that really cool stuff that maybe you guys are interested in. So again, no textbook is needed for this class. Again, if you have difficulty with some of the material, your actual textbook might have some more explanations if needed. Or I could point you into different videos or readings online. The grading, you get an F if you don't turn in stuff. And that would be pretty hard though, right? You guys are honor students, so I don't expect you, unless you have some difficulties, which you would tell me beforehand or when they're happening so that we can arrange make it work. But basically you would get an F or a D if you just don't turn anything during the semester. Homework is 40% of your grade. Class participation is 30% of the grade. Attendance is 10% of the grade, and the written project is 20% of the grade. So for you to get credit again, you have to make a B or better, so B or A. And usually everybody gets a B and an A in this course. So I don't think it's a class that would have, it has a workload, but it's not a course. Let me see, somebody's coming in. So my idea for this course is for you guys to have some fun, to learn about something new, and to not stress you by giving you exams or anything like that. You guys already have enough stress with your other classes. So this is challenging, but fun. All right, so let's talk about the grade components. As I mentioned, attendance is mandatory unless you have made arrangements with me before. These class meetings and activities are not echoing what you see in your physics course. And I also feel that this is the material that we'll be talking about is interesting enough that you would be really enthusiastic about attending. I also assume that for attendance, that to get the full 10% of the grade, and that most of you will get just the 10% perfectly, is that you would not be missing classes, you'll be punctual when you're here, and any excuse absence, discuss with me as early as you can so that we can arrange for makeup work. The other big component is, the next big component is your written projects. You're gonna have 2 short written projects during this class. And I'll provide you with information during the semester. So 2 short written projects, that's it for the written project. Now, when I get evaluated for the course, you guys get the chance to write evaluations at the end. I have gotten people that complain about having to do a writing project in a physics class. So I think that writing is really important because it doesn't matter what you are doing, what kind of degree you get, whether it's engineering, whether it's physicist, any scientist, any engineer, is gonna have to be writing a lot. So maybe you don't agree at this point that writing is important, but it's something that we don't emphasize enough in our degrees. So writing is really important, and I think that you should get as much technical writing and other kinds of writing experience as possible. Okay. Questions? At this point, I'm not seeing the questions because I'm sharing the screen, but if you have questions, let me know.
Sorry, I just got disconnected somehow. I didn't mean to leave.
All right, so let me see if I can see the chat. Chat, because I see something here in the chat. All right, got it. So now I open the chat. Cool. All right, so, all right, participation in class. In this class, sometimes you're gonna be asked to share what you did for solving some of the exercises that we're doing. So you'll be sharing what you did, and there's 2 people. So you get to share your work with the rest of us, and I'll be working as the moderator, but then you're the instructor for that particular topic that you're covering. Now, the rest of the class, the ones of you that are not presenting, you also have to be actively engaged in the presentation. So that means that you're checking that you understand so that the presentation is clear, that you're convinced, and if not, you should speak up. So when you're speaking up, you're helping the presenter grades. So that's a weird font that happened right here. The presenters, it should be this apostrophe, and somehow it looks like a weird O. And it's also here. I don't know what happened there. That was when it was converted to PDF. And then you'll get a participation grade, both when you're presenting, and sometimes I'll ask you to contribute for something. So I'll pick on you. I'll look at the screen, randomly choose one of you. Whoever gets asked to talk about something, you're getting participation grades. Then homework assignment, some of the time the homework assignment is what we do in class. It's not really homework, it's classwork that you're just turning in the next, before the next class starts. And to be fair to everybody, homework will not be accepted after the due date, except in extenuating circumstances. And just let me know if you think you have an extenuating circumstance and you need an extension, and we'll work with that. If you're stuck with something, you should come and ask me. I don't want you to spend 10 hours working on a homework assignment for this class. And I'll give you hints and not ruin the fun of discovering how to solve the problem. So more stuff about attendance, absences, and tardiness. I think I just discussed this already. And then the student with disabilities, we have a method where I get an accommodation letter. And I think that the student is supposed to be the one asking for it to be sent to me. So I haven't received any, but if I receive it, they usually doesn't have the name of the student. And therefore, when I get one and I need to match it up with the student, it's a lot easier if we just discuss it, and we could discuss during office hours to see what is needed from the accommodation letter. Especially because most of the time it could be that you just need extra time and stuff like that, and we can fix it right away and make sure that that happens to consistently throughout the semester. All right, so everybody is familiar with the academic integrity in our university, right? You guys have seen this. Again, there's a typo right here. I think this is supposed to be the comma dot. And the homework here that you were gonna be given, it might be that you get your answers from an unauthorized source. So maybe you find a solution to an exercise that is given, and it looks exactly like, you give me your homework and it looks exactly like something you would find from Google, right? Or Check, or whatever other thing. If that happens, then that could be an academic integrity violation. And I'll have to write it up and send all of the stuff out, and then we'll have to meet, and you guys know how that goes, right? Or hopefully not. So it's not worth it for you to do that. But if it's the first time, it's not that bad, because you might get just a 0 on the assignment if you did it. However, if you do it for a second time, it's really bad. So the academic integrity consequences are very severe once you do it a second time. So I think that the first one is, it might be for an education purpose. However, there's something really important here. One of the big graded assignments is gonna be the write-up. And if I ask you to do a write-up, and then your write-up is exact word for word, or maybe not even word for word, it has plagiarized from different sources or something like that, then that would really hurt you. So don't do it. And even if you feel a crunch about turning something in and you think like everything is caving in because you're not able to turn in an essay, it's a lot worse to turn in something that is plagiarized. So that's a big no-no. Any questions about that? All right, so I would ask you to go through this part and read it carefully if you're not familiar with our academic integrity. If you have a disability and an accommodation letter is going to be sent to me because of that, I ask you to meet with me to discuss it, and we can make sure that all of the accommodations are done correctly. Withdrawals, this is just a note, the OSU drop and withdrawal policy is followed strictly. And in my end, what that means is that even if I wanted to let you drop the course after the drop deadline has passed, I cannot do that, okay? So that's all it means. If you have an issue with a question, or if you want to discuss something else, you can visit me during office hours. We'll do the office hours by Zoom. And then the rest of the stuff, if you have questions about it, just let me know by email. All right, so for right now, what I wanted to do is get to know you a little bit better. So how about we do the following? I'll pick on somebody and then you'll tell us your name. Where are you from? What's your major? And your favorite food. Okay, so let me write down that down on the chat so everybody knows what we're, the order of things: name, major, where are you from, and favorite food. All right, so I pick on the next person, I'll say their name, then you just say those things, and then you pick the next person and the next person and the next person, okay? So let's go with Arthur James.
I'm Arthur James. My major is computer science. I'm from Enid, Oklahoma. And my favorite food, probably Chick-fil-A fries. Joshua, go.
My name is Joshua Davies, mechanical engineering. I'm from Edmond, Oklahoma, and my favorite food is Cane's. I pick Cade.
Sorry, your favorite food was, I didn't.
Oh, sorry, it was Cane's.
Cane?
Cane's, C-A-N-E-S, like Raising Cane's.
Oh, okay, got it.
I'm a mechanical and aerospace engineer, and my favorite food is probably Jared.
Sorry, I couldn't hear your food either.
No, sorry, it's pizza.
Pizza, okay. And you picked Jared, right?
Yes.
Yeah, my name is Jarrett. I'm also from Edmond. I'm a electrical and computer engineering major, and my favorite food is probably either ramen or sushi. I'll pick Christian.
Yeah, I'm Christian Tordik. I'm from Carthage, Texas. I'm a computer engineer, or electrical and computer engineer, and my favorite food is carne asada.
Awesome. And who do you pick?
Hattie.
I'm Hattie. My major is civil engineering, and I'm from Yukon, Oklahoma. And my favorite food is Chipotle.
Awesome. And there's one more person to pick, right?
Yeah, Chasen, sorry.
Hi, I'm Jason McPherson. I'm from, my major is physics. I'm from Minko, Oklahoma, and my favorite food is pizza.
Awesome. So we got everybody. Cool. So we have a couple more minutes. So how many of you got a chance to, I'm putting up a poll. Let's see. Yes, no. How many of you got a chance to see the video? Let me see how this works. Did you guys get a little window with a poll?
Yeah, I got a poll on my screen.
Yeah.
So let's see, it says 6 people, 1, 2, 3, 4, 5, 6, 7. 7. All right. Cool. So a few of you did, not everybody. And when I say share the results, you see that? See that? All right. So now let me see how this works. So I'm trying Zoom instead of Canvas because I couldn't stand Canvas last year. So let's hope for the best and that this is gonna be better. So the first thing I wanna cover is mention something about a special relativity. And I hope that you guys can read my handwriting. But if not, just let me know and I'll rewrite it and erase whatever is not legible. And special relativity, where did my mouse go? There we go. Is this thing that Einstein came up with in 1905. So if you see that video, you'll see how Einstein realized that certain things that are common sense cannot really be explained, especially our common sense of time is not there completely. And it is a question of who's right, whether Einstein was trying to figure out who's right. The speed of light doesn't change, or the way that we perceive space and time happening. So Einstein realized these shortcomings, and then he came out with this theory of special relativity. So how many of you are familiar with relativity? Just relativity, not special relativity, just normal relativity. What does it mean? Anybody?
That means two things perceive differently what happens based on where they are and how fast they're going.
Okay, and the main thing is that, right? For instance, time measurements. Let me give you an example of this. Let's say that we have an observer here. This is observer A. Yeah.
Sorry, I just wanted to let you know that if you're writing stuff, that I don't think we can see it. At least I can't.
You don't see it? Okay, I'm sharing a whiteboard with the screen. Oh, hold on. It says it's pass. There we go. Is that better?
Okay, yeah, that's better.
There we go. We can see it now.
All right. So this is special relativity. And the first thing we're going to talk about is time measurements. So let's say that we had two observers. A and B. So the first thing that I want to do is, let's say that there was an event happening. This event could be an explosion. So an explosion happens here. So this is event happening. And this is the first instance. Then we're gonna have at another time, there's the two observers, they haven't moved. And as you guys know, the speed, so the distance between event one happening and observer A is such that it takes some time for the event. So the event is, the light of the event is traveling, and at this time in instance B is when it hits observer A. But then there's also an event 2 right here, maybe another explosion or something like that. And this is event 2. And then we're gonna have a third instance, let's call it C. We have our two observers here, A and B. And the light of event 1 is reaching B at the same time as the light of event 2 is reaching B. All right, any questions about that setting at this point? So the first thing is, so when we measure time, let's see, spotlight, there we go. All right, so when we measure time, in this case, we could have a final thing where the light of event 2 reaches this observer, right? And then if you ask A, observer A and observer B, did these two events happen at the same time? What would A say? No, right? But what would B say? There,
B would say yes.
because he gets notice of this event and this event happening simultaneously, right? So who's right?
They both are.
Exactly. And we have two events. We have light being emitted from two different locations, and light signals. So in this case, a flash, an explosion, whatever it is traveling at a speed of 3 × 10⁸ meters per second. So that's 300,000 kilometers per second in vacuum, right? In air, it's a little bit slower than that, but not so much slower. And the information of this happening reaches this person at this particular time. The information of this happening reaches this person at this particular time. So at this point, even though this event already happened, at this point, even though at B, this event already happened, actually this event, A and B, will both say hasn't happened yet. They would say that's in the past and it hasn't happened yet. But then at this point in time, this guy would say, oh, E1 and E2 happen simultaneously. So the observers do not agree on the sequence of events. For observer B, the observation is that they're both emitted, they both got to him at the same time, so he thinks it's simultaneously. and so forth. So this is not such a crazy idea that something happens and we don't realize it has happened. For instance, let's say that the sun all of a sudden had a sudden flare, right? So if it happened exactly at this point at 11:07, it wouldn't be until class finishes at 11:15 that we would realize, because the solar flare is happening so far away from us that it would take those 8 minutes to get here. And we wouldn't know that it's happening because there's no way for us to know what's happening near the sun, that it's 8 light minutes away from us. The information wouldn't travel to us in time to be aware that there's a solar flare coming. The solar flare would just fry all of our communication instantaneously, right? You guys know about solar flares, I'm assuming. Everybody familiar with solar flares, or somebody that has never heard of that event?
Yeah.
All right. So solar flare happens, it takes 8 minutes before we observe it. Something happens in another galaxy, like closest galaxy that we have is the Andromeda Galaxy. It would take about 2 million years to reach Earth information. So basically, if you ever see the Andromeda Galaxy, you look up at the sky, any light that you see was actually leaving the stars from the Andromeda Galaxy 2 million years ago, before even humans were around. So we don't even know if that galaxy is still there, right? It was 2 million years ago that it was occurring. So this separation of the events and the signal delay complications is one of the things that Einstein was thinking about. All right, so let me give you another example. Let's say that there's 2 events. So this is similar to this one here. Let me make my event. So here's, oops, I need to change from Spotlight to drawing. So here's an event, event 1. And then now we're gonna have some observer, assume it's you. And this observer is running and is carrying a clock with them and knows that the clock is there when passing by event 1. So this is the first case, A. Then in the second case, you still have your giant clock and you're walking with it. You're walking, and now your clock is here. And then in this third instance, this is you again. And you were still walking and running and whatever you were doing with your giant clock in your hand, and the clock is now down here. But not only that, there's an event happening here. Something flashes over here, and that's event 2. All right, so in this figure, what I'm trying to show you then, if we have an event that is separated by a significant distance, it doesn't have to be astronomical, but it could be, right? And in this case, there's some distance from whatever event 1 and event 2 are happening, very similar to what you see over here with 2 events. But the difference is that now you have a person that is positioned exactly in space where event 1 was happening, and that's when they start taking their time, and then they move and are positioned exactly where event 2 is happening, and they have the time interval between this one and this one. So the observer, in this case you, is traveling from location 1, where event 1 happened, to location 2, where event 2 happens, and is recording on the same giant clock when this happened and when this happened, and can tell you how much time passed in between. One thing is this person, you, is traveling at a constant speed. This is one of the limitations of the special theory of relativity. If you start accelerating, then you're not in the special theory of relativity. So you shouldn't be accelerating. So you're traveling at constant velocity. But the time interval that this person measures from here to here is called the proper time interval. So this is an important definition. This is the proper time interval. And let's compare it with the time intervals that would be measured between events for this particular event 1 and event 2. For this particular person positioned here, let's assume that this is the same unit of time. So it's 0, 1, 2, and then 3 over here would be when this light reaches the sky. So what is the time interval that is measured by B? 0, right? They're simultaneously E1 and E2. But the time interval that would be measured by A is not 1, but rather 2. And the time interval that would be measured if somebody was traveling from here to here would be how much? So this is the question for all of you. Anybody? Or you guys want to do a poll? So in this case, event 1 and an event 2, there's another observer that goes in between the two. What is the time interval that they would see? Is it 0, 1, or 2? A, B, or C, 0, 1, or 2. So if you want to put it on the chat and then press enter, that would help a lot.
What speed are they moving at?
You don't need to know the speed, right? We're just looking at what is the time interval. The proper time interval between event 1 and event 2 in that they're traveling from one to the other. Assuming that there's one unit of time as you go from A, B, C, D in each of them. From A to B, there's 1. From B to C is 1. From A to C, there's 2, and so forth. So how much time did it take, proper time, did it take between event 1 and event 2?
Would it be 2?
You're thinking 2?
Mm-hmm.
Anybody thinks something else?
This for the explosions on the left, right?
Yeah, for the left.
Okay.
So let me see if I can share the screen again. The whiteboard. All right. So let's do the following. I'll write it up and give it to you guys as your first homework assignment, okay? Now I need to figure out how to save this. All right. So if you guys don't have any questions, you just have to answer this. I'll put in the homework assignment on Canvas. You'll get till before next class. And then if you don't have any questions, this is it for today. If you have questions, just let me know, okay? All right. Well, nice meeting all of you, and I'll see you next week. Thank you.